Hello all. I'm delighted to introduce to our project called the JusticeBot, a virtual legal assistant. It is an innovative retrieval-augmented generation based chatbot which is developed by me and my teammates. It is designed to transform access to legal information, and JusticeBot leverages advanced AI technologies in order to simplify the legal processes and provide us with instant, accurate, and user-friendly guidance. So what our JusticeBot is all about? As we mentioned, it is a retrieval-augmented generation based chatbot, a RAG based model. It is designed to revolutionize access to legal information provided by the Justice Department of India. Utilizing advanced language models, which is the Gemini Pro in our case, and a cutting-edge AI technologies, JusticeBot delivers immediate, accurate, and user-friendly support, a broad spectrum of legal and judicial services. It simplifies complex procedures by providing detailed explanation and step-by-step instruction, enabling users to efficiently navigate their legal needs. The main highlights of our JusticeBot project comes with the motto that it is justice within reach. So the JusticeBot aligns with the key sustainable development goals, which includes the goal 16, which emphasizes peace, justice, and strong institutions by fostering accessible justice, and goal 10. So what is our problem statement? The current access to legal information and services through the Department of Justice, which is the DOJ, can be cumbersome. It is complex, it is time consuming for both legal professionals as well as the normal public citizens. Navigating various judicial processes such as case status, inquiries, court hearings, e-court services, filings, payment rules often requires users to go through a vast amount of legal information, a complex route of navigation, leading to confusion and inefficiency. In order to address all these challenges, there is a need for a robust solution that can provide us with an instant access to legal services and information in a user-friendly manner. A system capable of retrieving legal data, answering queries, and guiding users through complex procedures while ensuring transparency and accuracy is very crucial. Additionally, the solution must be very much scalable in order to support a large use case basis, and provide us with a 24/7 availability and offer personalized responses to the legal inquiries in real time. This is our architecture diagram of our JusticeBot project. So it provides a clear overview of how the system components and their interactions, illustrating the flow of information from the user end to the final output. The diagram outlines on how each component, which includes your front-end interface, back-end processing, and external data sources, is interconnected to enable the chatbot's functionality. By visualizing the entire workflow, the architecture diagram demonstrates how the system retrieves the legal data, processes the user request, and delivers the accurate responses to the user. JusticeBot architecture integrates various components, which includes a front-end developed with HTML, CSS, and JS, a back-end powered by Flask, and a vector store for data retrieval using FAISS. The front-end captures user queries, which are then sent to your backend for processing. The backend is integrated with your Gemini Pro large language model, and it retrieves all the relevant pieces of legal data which is stored in your vector database, and it formulates the responses in the LLM based on the retrieved information. The final response is then displayed to the user on the front-end part. So now let's dive into our code base on how we develop this JusticeBot. So here we have with us the main backend file, which is the app.py, and that's our file structure. And we have all the necessary front-end and backend files under one directory. Now, these are all the necessary libraries that is imported in your app.py. And this we have the API of your Gemini model stored in .env file and is called to your backend app.py route. And now we have the datasets folder where all your PDFs that you are going to train your RAG model with is stored. So all these PDFs are basically scraped from your DOJ website of India. So as of now, we have worked with a limited set of PDF due to a lack of computational resources. This is our one of the Act 7 PDF file. Now getting back to our app.py, here the first initial function that we have is getting all the PDF from the text. So we are first opening up your path, file path, and then we're going to split this file into chunks. So using the recursive character text splitter, we're going to split the chunks of each 500 size, and the whole PDF document is now going to be stored as chunks. Now these chunks are then going to be converted into embeddings in order to store in the compatible vector store database. So we are converting them using the Google Generative AI embeddings and storing them into the vector store known as the FAISS, which is the Facebook AI Similarity Search. And then we're going to initialize your vector store, which is our FAISS. And we're going to store all the vector embeddings that is converted into the vector store. And now we're going to define a function, a conversational chain, where we define a prompt template on how our chatbot must respond to the user based on corresponding to the query that is given. A detailed list of how the response must be generated is mentioned in your prompt template, and also on how the response has to be developed at the final output is also to be given in your prompt template. And now we have the model where we use the chat Google Generative AI, and the model is the Gemini Pro, and we have set the temperature to 0.3 and call the API key that we have stored in .env file. And then the prompt template is called along with the input variables, which is nothing but context and question, and then we are creating the chain with them. Then we have the function, the user input, and finally we have a Flask part where we integrate this whole backend model with our front end. So as you can see, it is routed, and you can see a file name where we render the template known as index.html, and it is stored in the templates folder. So this is our index.html, which is the front end UI, basically where we are integrating our whole LLM and AI model. And for that particular HTML file, we have the styles, the images all stored under your static folder. So this is the basic file structure of a project. So now let's try running our project. So we're going to open an integrated terminal, and we are going to give in python app.py command in order to run your project file. So now let's click on to the root, and this is our JusticeBot front-end interface, and we have some sample prompts that's given as cards in the initial part and the features of our JusticeBot. And now let's type in hi, and we get an intro from JusticeBot saying, hello, I'm here to help you with any legal questions. So it's giving you a friendly kind of response, starting off a good professional way. Now let's giving the question, what is contempt of court tax? Okay. Now let's see what our JusticeBot is generating, and here we have contempt of courts app. So basically this response is nothing but which is generated from the loaded PDFs that we have given at the project end. So it takes in the all the necessary details that maps with the keyword of contempt of court acts, and it fetches all the related chunks and gives us the curated response in the LLM. The next question is, we have what is POSCO Act? Okay, well, I guess there's an error in the query, but however, you can see that our JusticeBot has fetched the right answer, correcting the part over here, saying the query is POSCO, but then however it understood and it clearly got as a correct act, which is the POXO Act. Now let's check how exactly or correctly is our LLM generating from the given PDF set. So here we have the Judges Inquiry Act. So let's ask like, when was the act found? When was the Judges Inquiry Act found? And the LLM has responded, enacted in 1968, and it is the exact information correctly given in the PDF. So we have verified that the JusticeBot, that is our project, is correctly trained with a given set of PDFs and is returning accurate responses. So in conclusion, the JusticeBot a virtual legal assistant that we developed demonstrates a significant advancements in providing accessible, real-time legal information to the users. Leveraging retrieval-augmented generation technique, JusticeBot is specifically designed to assist the users in understanding and navigating common legal scenarios from contract disputes to basic legal rights. Through and through the testing, our system has shown impressive accuracy and efficiency in retrieving relevant legal information that is stored, making it a practical and a valuable tool for both legal professionals and individuals seeking legal guidance. JusticeBot holds a very immense potential for integration into legal aid and support systems, which offers a streamlined solution for individuals who might not have access to legal counsel but delivering the timely and relevant legal information.